Okay, so today's target is we're going to be practicing the balancing method to solve equations. So previously I showed you guys how to do the do-undo table to solve equations, and that was pretty successful. Well, today we're going to start focusing on a different method called the balancing method. It's very similar to the do-undo table. It's just instead of writing out the table, we're just doing two types of properties, additive inverse and multiplicative inverse to solve equations. So I'm going to go ahead and just model the first two equations. Whenever you see a little red tile, that's a -1. Whenever you see a long rectangular tile like this, that represents a negative x. When you have a green rectangular tile that's longer, it's going to be positive x. And then a white tile will represent a positive 1. So let's begin. Make sure you list this in your notebook. Remember the solving equation is really about balancing, making sure that the left side and the right side is always balanced. Or in math, balance is represented by the equal sign. So right here, this says, how would you use these tiles to represent 2x plus 3 is equal to 7? So let's do this real quick. 2x. So I have 1x, 2x. That means I have two groups of x plus 3. 1, 2, 3. What I know is these two tiles and these three white tiles is 2x plus 3 has to equal to 7. So I have 1, 2, 3, 4, 5, 6, 7. So I just want you guys to picture this visual model while you're solving equations. Our job is to figure out how many white tiles are in each of these long green tiles to make the left side equal the right side. So first thing we're going to do is I'm just going to show you how to model this and solve it. We have positive 6 on the left hand side of the equal sign, so put positive 6 right there. That's positive 6, and I have a negative 2x on the right side. So there's my negative 2x. Excuse me, it's going to be negative 2. Negative 2 plus 4x. 1, 2, 3, and 4. Coming up here. Alright, so if you look on here, I need to figure out how many green or red or tiles are in each of these any white tiles are in each of these green tiles to make the right side and the left side balance. So what I need to do is I'm going to get all my variables and all my numbers on one side and the other. So since there are already 4 green tiles on here, I'm just going to leave that. And I need to get rid of these 2 red tiles. In order to do that, I'm going to add, called the additive inverse, 2 positive white tiles. Why did I do that? Because it cancels it out. This one and this one equals 0. This one and this one equals 0. So the rule of mathematics says that if I add positive 2 to one side, I also add 2 to the other side. So there's 1, 2. And then I remove whatever I can, so those red tiles are gone. And then I have 4 groups of x, or just 4x. What I'm going to do is I'm going to break that up. In mathematics, breaking it up is the same thing as saying dividing. So I broke that up into 4 equal parts, or 4 equal x's. Therefore, I need to break these white tiles into 4 equal parts. There's 1 group, there's 2 groups, there's 3 groups, and there's 4 groups. So what that means is each of these x's and each of these bars, each x is equal to positive 2 because we broke it up into 4 groups, and we also broke up the other side of the scale into 4 groups. Now, yeah, some of you might skip this part and just move on straight to the mathematics part, but make sure you guys see the visual model and so we practice in class as well. Now let's get into more algebraically speaking. The first thing I'm going to do with any other equations is I'm going to box each term. I'm not even going to worry about the do-undo table today. I can model this for you if you want, or you can do it in your notes. But what I have is I have 2 red bars, 4 white tiles, and 10 red tiles. The first thing I need to do is I need to get rid of whatever is farthest away from my variable. Here's a positive 4. So I'm going to do the additive inverse of positive 4, which is negative 4. Negative 4. Whatever you do to the left side, you have to do to the right side. Kind of think of it as you're splitting down the middle. I always like to draw my line underneath of it and then cancel out whatever cancels out. Bring everything else that you didn't touch or played with, and now I have 4 with negative 4 is 6. Now, what can I do to negative 2 to make that a positive x? What I'm going to do is I'm going to, since this is multiplying by negative 2, the opposite of that, kind of like the do-undo table, is dividing by negative 2. So I'm going to divide that by negative 2. This becomes a positive 1x, or just x, is equal to 6 divided by negative 2 is negative 3. And there's my answer. Each of these x's is negative 3. Please also make sure that you double check your work. So what I'm going to do is put it back into the equation. Negative 2 times negative 3 plus 4 is equal to 10. So what I know is negative 2 times negative 3 is positive 6 plus 4 is equal to 10, and 10 does equal 10, and that checks. So my answer is negative 3. I'm going to go ahead and pause this, and won't you pause it, write this problem down, pause it, and try it, and then I will continue to move forward, and then we can compare answers here in a second. Before you pause it, let me read this to you. A number is divided by 4 plus negative 6 is equal to negative 5. Okay, go ahead and pause it and try it. Okay, so the first thing I'm going to do is I'm going to box each term using the balancing method. And what I know is that I have a negative 6 plus a number divided by 4 is equal to negative 5. The balancing method tells me that I need to get rid of whatever is farthest away from a variable or not attached to the variable. So this negative 6 is not attached to the variable at all, in the fact that it's not closest to it. It's not in the box with the x. So what I'm going to do is I'm going to do the additive inverse of negative 6, which is positive 6. I'm adding 6 to both sides. Because you multiply or divide, you always do that last. You want to get rid of everything that's just hanging out there by itself. This cancels out. That's 0. I drop everything down. I get x divided by 4 is equal to 1. Now here's the tricky part. I have some number divided by 4 is equal to 1. You ask yourself, how do I undo dividing by 4? Well, what I'm going to do is I'm going to do the multiplicative inverse. Basically you're asking yourself, what can I multiply by? There's really a 1 right here. 1/4 of x equals 1. So what I'm going to do is I'm going to multiply both sides by 4 over 1. You see how I just flipped that, the reciprocal? That's called multiplicative inverse. Because this and this becomes 1, and this has become 1. And all that's left is my x. And since I multiplied the left side by 4 over 1, I also multiplied this side by 4 over 1. Yeah, some of you are going to ask, can I just multiply both sides by 4? Yeah, and in theory, that's what's happening, but really, if you're dividing or multiplying fractions, make sure your whole number is also a fraction. Here, I have 1 times 4 is equal to 4. I have 1 times 1, because 1 over 1 is still 1, so 4 over 1 is still 4. So my answer is 4. Now look on the screen, look how I unbalance everything. What I did was I got rid of that negative 6 by doing the opposite of that, which is positive 6, or add 6. The opposite of dividing by 4 is multiply by 4. So this way is a little bit quicker. You don't really need to do the do-undo table, and we're going to start practicing this and get a little bit more efficient in this in class. All right, so let's move on to this one. This one's kind of a little tougher one, but what I'm going to do is I'm going to box each term. Notice how I box the whole n plus 5, because it's all on top of the numerator. You can't just box the n and box the 5, because they're both on top of the numerator, so therefore they belong together. I have a negative 16, and I have a negative 1. First thing I need to do is get rid of whatever is not attached to the variable. Notice how the n plus 5 is pretty much inside the box with the n. So what I need to do is I need to get rid of this dividing by 16. What is the inverse of dividing by 16? It's multiplying by negative 16 over 1. Because this is a fraction, and I need to pretend there's a 1 right here. So it's 1. It's negative 1/16. The opposite of that would be negative 16th 1. Why? Because I'm going to cross multiply, and what I know is these become 1, and all that's left is n plus 5. Since I multiply the left side by negative 16 over 1, I better do the same thing to the other side. I'm going to multiply this negative 1 by negative 16 over 1. You can turn this negative 1 whole number into an put a fraction. Negative 1 times negative 16 is equal to positive 16. Remember that a negative times a negative is positive. 1 times 1 is 1. So I have n plus 5 is equal to 16. And then from here, you ask yourself, what is the inverse of adding by 5? Well, that's going to be minus 5. And n will equal 11. Make sure you double check your work. 11 plus 5 is over negative 16 is equal to 1. I know that 16, excuse me, negative 1. 16 over negative 16 does equal negative 1. Negative 1 equals negative 1, and that's our goal. So our final answer is n is equal to 11. So look on the screen. Notice how I got rid of that dividing by negative 16 first because it's kind of far away from the variable, and that's what we want. We want to just unbalance everything or balance everything. So whatever you do to the left side, you do to the right side. Basically, it's the same thing as the do-undo table. All that we're doing is we're not drawing the table. We're just doing the undo part of it. Okay, make sure you list this, and we'll talk about it in class.